So you just learned how to build a web app which has user authentication in your college or university. It's easy, right? You tell your user to register, they send their email, username, password, you store the data, you store the password, and when the user comes to login, you just check the username and the password and you are done, right? Wrong. What you just made is a nightmare. I mean, if you are building this for a side project or for learning, that is probably not an issue, but if you try to apply the same knowledge in your real world, you will soon meet with difficulties because you are storing your password in plain text in your database, which is a big nightmare. I mean, if someone somehow gains access to your database, every user in your site has their password leaked. That is a blunder. Now you are not alone. I am not going to name anything, but during my college applications, I have applied to some colleges, some big names, some internationally famous colleges, which store their password in plain text. Not only that, they send you an email where they write your password in clear text. That is horrible. I mean, it's like a story from nightmare. So if a reputed institution can do this, imagine how deeply rooted the lack of proper knowledge is in our students. So in this video, I will show you how to properly store your password. Instead of storing it in clear text, how you can hash your password and increase the security of your web app. So let's get started. Imagine you want to send a letter to your friend. So you do not want anyone else to read it. So what you do, you encrypt the letter. And by encrypting I mean, imagine putting a lock on it. And only your friend owns the key to this lock. So he or she can decrypt it and get back your original letter. So this is what I mean when I say encryption. However, in case of passwords, encryption is not very useful because encryption means there is a possibility of decryption. So you can get back the original password if I give you the encrypted password, which is not an ideal situation. So for password, we use something called hashing. So just for an analogy, hashing means something like you have some ingredients for making a cake. So hashing will be making the cake. Now of course, if you have the ingredients, you can make a cake, but you can't go back. So from the cake, you can't recover all the ingredients. The similar thing happens with hashing. If I give a password and hash it, you cannot bring back the old password. Now, I am not saying it is impossible, but it is computationally infeasible, which means that our current technology does not have enough power to reverse the hash. So what is hash? So hash is a mathematical function. Now I'm not going into exact detail about how this function is constructed, but imagine it is a one-way function. So it takes as input one string, this is the original password, and it converts it into a fixed length string, which is the hashed value. Now you might wonder, how does this help us? I mean, it's still a string, right? Now here's the thing, as I said before, from this string you cannot go back to the original password. It is essentially a one-way path. So even if someone gets access to our database and sees this string, they cannot recover the original password, which is ABCD in this case. Now a hash function has some useful properties. So the first property is that it is easy to compute the hash, but it is very difficult or downright impossible to regenerate the original input, as I said before. And second is that it is difficult to guess or create an initial input that will produce a desired output. So I have already explained the first point, but let's see an example of the second point. We have seen this hash before, and as in the example, this was the hash of the string ABCDE. Now, can you guess what could this be a hash of? As you can see, these two hashes are wildly different. I mean, there is nothing is common about them. So you might guess it is something like maybe a hash of XYZ, maybe a hash of hello world, something like that. But you would be surprised to know this is actually the hash of ABCDF. As you can see, changing the last character has such a wild effect on this hash, which is known as the avalanche effect. So basically, if you change one character, your entire hash will look different. This protects from guessing the hash. I mean, if changing one character in the password changed only one character in the hash, it would be easy to guess. If I knew that ABCDE produces the first hash, and if the second hash looked similar to this, I would know that, okay, something is common between them, something is similar between them. But here I cannot guess at all by just eyeballing the hashes. So how can we incorporate this hash function into our usual web app flow? This is very easy. So the path will be like this. So when registering, the registration data will be sent to the server. Here, instead of storing the password directly, we will first hash the password and store the hashed value. And now when the user tries to log in, we will collect the login data, which will be maybe just the username and password, or the email and password, whatever. Here we will first select the user with that email, and we will hash the password that the user is sending right now as part of its login, and then we will compare the two hashes. So if the hashes match, it means the password is correct, and if the hash does not match, it means the password is incorrect. So now our life is very easy, right? We have a secure password in store. But think again, there is still some problem. Let's see. So suppose I am storing the hash right now, and someone gets access to our database. So imagine this is our database. So the first column is the username, and the second column is the hashed passwords. So you will notice right away that Mike and Alice, they have the same hash, which means they are using the same password, which is this. Now if I am an attacker and I have access to this database, and I see that two people have same hash, it means they have same password. So if somehow I can get access to the password of one of them, I can get access to the password of both of them, essentially. So if somehow I extract the password from Mike, I also know the password of Alice. Now extracting a password is not too easy, as I said before, because it's impossible to generate the password from the hash. But what I can do as an attacker, I have more or less three general ways. So the first way is a brute force attack, which is basically just trying random words until I can match the hash. The second way is a dictionary attack. In this case, this is also similar to brute force, but in this case, instead of trying random combinations, I will try some pre-arranged words. Maybe it could be a list of common passwords, or maybe some words from an English dictionary. I will try this until the hash matches. Now here's the problem. The first person in our database was using a word as his password, which is commonly found in English dictionary, which is hello. So now if I use a dictionary attack, he is in trouble, because his password will be cracked, because it is a common word. However, the Mike and Alice, they are not using a common word, so they are safe for now. However, I have another method, which is known as the rainbow table attack. So rainbow table attack is basically a table of pre-computed hash. Now if you look at dictionary attack and brute force attack, they both require real-time computing. So you are trying passwords one by one, so you have to calculate the hash every time. But in case of rainbow table, you already have calculated hash, and you are just checking the hashes. So this is very fast. Now imagine if somehow their password is present in the rainbow table, both Mike and Alice are done for. Even if their password is not in the rainbow table attack, there are other ways to extract password, for example phishing or social engineering. So if somehow one of them discloses their password, the attacker basically has access to everyone who is using the same password. This is a danger. So we have to mitigate this. And the way we do this is by using salting. Salting is the technique where we add some random value to the password before we hash. So we either add it to the front of the password or add it to the end of the password. And this value is unique for every user, and it should be cryptographically strong. So now for an example, let's say for Mike, we are using the salt hi Mike, and for Alice, we are using the salt hi Alice. Now this is not cryptographically strong, but assume it is. So how will we calculate the hashes? So first, in case of Mike, we will take his password and add his salt to the front of it, and then hash this new value. Similar we will do for Alice. So in her case, we will use her own salt, which is hi Alice. So as you can see, even though they are using the same password, their hashes are now different, because before hashing we are changing the password. So now with the hashed password, we will also store the salt, and our registration and login flow will change a little bit. So now first the registration data will be sent to the server. Then instead of hashing the password directly, we will first add the salt to the password and hash it, and store both the password and the salt. And during login, we will take the login data, we will add the salt to the password and hash this new password, and then compare the hashed password. So here I have one more step, which is the salting, and we have to store another thing, which is the salt. So in database we will have to add another column. Now if suppose an attacker has computed a rainbow table. So for example here, let's say the attacker has some passwords and their hashes pre-calculated. Now if I have stored the passwords with the salts and the attacker has access to the database, he can see the salt directly. But now this rainbow table, this is useless, because all my passwords are now salted. So he has to salt every password like this and calculate the hashes again, and he has to repeat this step for every single user. So if he had 10 passwords in his rainbow table and I have 100 users, he has to now calculate 1000 passwords or 1000 hashes. So this way we have significantly slowed down the attacker. Now this is not quite secure. I mean, if you are using a password that can be guessed easily or that occurs in a dictionary, even after salting your password is still weak. So the attacker might compromise 1 or 2 accounts. But we have slowed him down. And we have quite a lot of time to recover in case a breach occurs. So as for the demo, I have made a really simple app in PHP. Now if you do not like PHP, that's alright. I mean, I don't personally like to. But since PHP is probably the first thing that people learn in college or university, and they are not really taught about this password encryption, so I guess PHP would be a really easy way to demonstrate this. Now it is very easy to do the same thing in other languages too. Just go to Google, search for password encryption followed by your language name, and you will get a tutorial. Now so let's see a demo here. So here I have a registration form. So here I can get a username and a password, and I will move to the login page, and my data will be stored here in a file or in a database. As you can see, I am storing the password in plain text. So this is what we will fix right now. And the login works also the same way. I will write my username and my password, and I am now logged in. Anyway, so let's fix this. So here's the PHP code for the configuration. So just pretty standard MySQL stuff, like the server, username, password, etc. Then inside the registrar, I have this form which makes a request to this register.php, and here I am just taking the username from the post data, taking the password from the post data, and I am just storing it into the SQL table, so without any modification at all. So I'm just storing the plain text username and password, and if the result is successful, I am redirecting to the login.php page, otherwise I am showing an error. And inside the login.php, I am doing kinda the same thing. So first I am getting the username and password from the post data, then I am selecting the user where username matches the username that is sent in the form and password matches the password in the form. So if I'm then counting the number of rows, so if count is 1, it means the password is correct. So I'm just echoing logged in. Now here during registration, you should actually check if the username exists or not. I'm not checking that because, as I said, that is really not the motivation behind this. I mean, I just want to demo the password thing. So you should add the check. So yeah, so here's what I want to fix. So let's first add the salting, or let's add the hashing. Now if you are using PHP version which is greater than 5.5, hashing the password is already included in your PHP version. So for that I am going to take my password and pass it through a function called password hash. So I'll pass the original password. Let me increase the size. So I'll pass the original password and I will use the bcrypt algorithm. So there are quite a few other algorithms. Bcrypt is probably the most famous algorithm right now. So I'm going to use this. Now you will observe that I am not adding a salt. That's because this bcrypt algorithm will automatically add a salt, and I don't have to store anything else in the SQL. The result that we will get after hashing, the salt information will also be stored inside there. So that's all about this in the registration. So let's register now. And now if I see the database, you'll see that we have stored a hash instead of the plain text password, and the salt that is produced is already stored within this thing. So we don't have to worry about storing a salt in our database. Now for the login part, we have a little bit more work. So what I want to do, instead of selecting the user where username and password both match, we will instead select only the user where the username matches, and then we will hash the password and we'll check if the hashed passwords match or not. So inside this if, so we do not need a count anymore, so let's remove that. So inside the if, we will call a function called password verify. So the first argument is the password that the user sent in the form, the plain text password, and the second argument is the hash. So this is what I will get from running the SQL query. So the row stores the user that I just got by selecting the username, and the password column stores the hashed password. So we'll just match these two, and if this is true, we will log in, otherwise we will show an error. So let's try this out. So I will use mic and my password, and I'm logged in. If I did a wrong password, I would get an error. So that's all about password encryption. Now I hope you know how to encrypt your password and secure your password and secure the storage of the password in your database. So this is of course not the only step you can take to secure your web app. There are other ways. I mean, you should obviously enforce security in your database level. I mean, it's better that nobody gets access to your database unless needed. But those are a little bit advanced topics. So as I said before, I personally believe that this should be taught in college or university just after you have been taught how to build a web app. Because these are really very basic steps, as you saw, not very complicated, but our students should learn about these, because when they go into the industry, they will create web apps, and if they do not know about it from the start, they will have trouble making proper softwares. So that's all.